Welcome to the Math Record. Today I'll be covering the ICTM State 2018 Division AA Algebra 2, which I'll be answering questions 9, 17, and 20. As usual, scroll down all 20 questions if you want to answer these by yourself, and I'll provide the solutions at the end. Okay, let's begin with number 9. All sides of an isosceles triangle has a integral length. Exactly when the altitude has an integral length, it is known that at least one of the length is 70. Determine the largest possible numerical area of such a triangle. So basically, we have an isosceles triangle. Let's make an altitude. And the reason I did this was because either the leg or the base is length 70, and it's definitely going to be the base because if the leg is length 70, which is the hypotenuse, then basically your base and your height is restricted by the Pythagorean theorem. That means your area is going to be minimized. So you want to have a maximized area. That means the base has to be 70. So if the base is 70, divide by 2 to get 35 here and 35 here. This is isosceles. So basically, let's call this x, and I'm going to call this x plus a. So using the Pythagorean theorem, we have 35 squared, which is 1225, plus x squared is equal to x plus a squared, which is x squared, plus 2ax plus a squared. So we cancel out your x squared. So 1225 minus a squared divided by 2a is equal to x. And that's the reason why I use x plus a, because we could get into this form. So the reason I did this was because if you kind of think about it, the area is 1/2 times 70 times x, because it's 1/2 times space times height. So if we want to maximize the area, we need to maximize your x. So to maximize your x, that means in this equation, to maximize your x, that means a has been minimized because a is taking away from your number. So let's say a is your smallest, which is a is equal to 1, because a has to be greater than 0. So the smallest integer would be 1. So if a is 1, x is equal to, using our calculator, 1225 minus 1 divided by 2, and we get x is 612. And that's 612, and this is 613. And now your area is 70 times 612 divided by 2, which is 21420. So this is probably gonna be your maximum possible area. So how do you check? Well, we know your base here now is 613. So 1/2 times 613 times your height is equal to 21420. And this height should not be an integer, because they said that in the sentence exactly one of the altitudes is an integral length, and this is gonna be the altitude with integral length. So no other altitudes had to be an integer. So if you check using your calculator, h is not going to be an integer. So that gives us that this is your maximum area. So that's all you need to do. Just use the Pythagorean theorem and then check using your calculator. Okay, now number 17. Let log x of 4 equals log 3 of x of 324. Determine the exact value of x. So first we'll just use log change of base to get log 4 over log x equals log 324 over log of 3x, which is basically log 3 plus log x. Now cross multiply to get log 4, log 3 plus log 4, log x equals log 324 times log x. Now move this to this side to get log 4 times log 3 equals log x times log 324 minus log 4, which is just 324 divided by 4 to get log 81. So we're just using log rules so far. So all we're doing is just using log rules. So to get log x, we just get divide both sides by log 81. So I'm going to put these two together, so log 3 and log 81 to get log 4 times log base 81 of 3. So we are using reverse base change, is equal to log x. So log 81 of 3, 81 is 3 to the power 4. So to get 3 to the power 1, we got to multiply by 1/4. So this is going to simplify to 1/4. And this will be 1/4 times log 4 equals log x. And then we could use basically the log exponent rule. So we can move this multiplier all the way to the exponent. So that means 4 to the power of 1/4 is equal to your x because log, so x is equal to this. So basically that gives us that 2 to the power 2 times 1/4 is equal to your x. So 2 times 1/4 is 1/2. So 1/2 is just a square root, so it's going to be square root 2. Square root 2 is equal to your x. And that is your answer for number 17. So just use your log rules and you should be fine. Okay, number 20. When positive integer a is divided by positive integer b, the remainder is 15. When positive integer b is divided by positive integer a, the remainder is 19. When the positive integer a plus b is divided by positive integer absolute value a minus b, the remainder is r. Determine the sum of all distinct values of r. So there's two cases. Either a is greater than b or b is greater than a. So let's just work with both of them at the same time. So a is greater than b. So if a is greater than b, a is divided by b to create a 15. So if a is greater than b, that means a is equal to some kind of value for b times some kind of constant. So let's say k is your constant times b plus your remainder, which is 15. That's basically what they're saying in the first sentence. And then in the second sentence, when b is divided by a, the remainder is 19. So remember, a is greater than b. So let's say a is equal to 2 and b is equal to 1. So if b is divided by a, 1 divided by 2, you see that the remainder is equal to the smaller number. So that means b has to be 19. Okay, so b is 19. Now let's say b is greater than a. So if a is divided by b, right, because a is less than b, then basically a is now 15. And that means b, and when b is divided by positive integer a, the remainder is 19. So it's going to be some kind of other constant. Let's call that c. So c times a plus 19. Okay, so one of these statements is not true, and you could probably guess which one. It's b is greater than a. And the reason is because if you kind of think about it, if b is divided by a, you get a remainder of 19, right? But b is greater than a, right? If b is divided by a is 15. That means there's no way to get a 19 because that means somehow the remainder is 19 out of 15 at some point, which doesn't make sense. So this is not possible. So this is not true. So it makes sense for a is greater than b. And another way to do this without checking is basically they set the absolute value of a minus b. And that's probably a way to tell you indirectly. So using this case, what does that basically tell us? Positive integer a plus b. So a plus b, so k times b. 15 plus 19 is 34. That's a plus b. And then absolute value of a minus b. So a minus b is k times b. Minus 15 minus 19 is minus 4. So when we have k times b plus 34 divided by k times b minus 14, it has some kind of remainder. And remember, b is equal to 19, so let's substitute that in. So 19k plus 34 over 19k minus 4. And now all you have to do is just check using some integers. So let's say k is equal to 1. So that will be 19, and that's 53. And that means the bottom value is 15. So 15 times 3 is 45. And 53 minus 45 is 8. So your remainder is 8 because this number has to be less than this number. So that means your remainder is 8 here. Let's say k is equal to 2. Plug in 2 here. That will give us a 72. So, and then from this value, this will be 34. So this would give us 68. 72 minus 68, that is 4. Okay. So that's remainder 4. Now let's say k is 3. So we're just looking for all possible values for r now, because these are the remainders. So if k is equal to 3 at 19 here, so that's going to be 91. At 19 here, that will equal to 53. So this can only go one time, and the remainder is going to be 38. Okay, let's say k is equal to 4 now. So this would be 110, and this would now would be 5, 6, and 72. And then this will also be 38. So we could stop there because it's probably just going to be 38, 38, 38. And you could use your calculator to check. So the only possible distinct ones are 8, 4, and 38. And adding them together, that is your answer for 50. And that's your answer for 20. Your answer is 50 for question 20. And here's are all your answers for all 20 questions. Well, thanks for watching, and I'll see you at the next math record.